Hello everyone and welcome to this explainer. I am super thrilled to have you here today because we're exploring one of the absolute most essential building blocks in all of programming. We're going to master Python strings. Now, it's really easy to just think of strings as plain text, just words on a screen. But today, I want to completely reframe that for you. I want us to start looking at strings not just as static text, but as dynamic raw materials. They're these incredibly versatile building blocks that we can actually shape, mold, measure, and construct with to build incredibly powerful software. So even if you code every single day, it's time to stop taking these basics for granted and start treating Python strings like a true, heavy-duty text handling toolbox.
Okay, let's dive right into this. Here's our roadmap for the explainer. 1. What are Python strings? 2. Indexing and slicing strings. 3. Essential Python string methods. 4. Formatting with f-strings. And 5. Real-world string applications.
So, starting off with Section 1, what are Python strings?
Quite simply, a string is a sequence of characters enclosed within quotation marks. Honestly, it's one of the most commonly used data types across all of programming. And notice I said characters, not just letters. A string can absolutely contain standard alphabetical letters, sure, but it can also hold numbers, spaces, and special symbols. So why does this matter? Well, because strings are the primary way we handle almost all human-readable data in real-world applications. Think about it. Every time you log into a website, your username, that's a string. Your secure password, also a string. Your email address, your physical address, the chat messages you're sending to friends, the actual content on a web page, it is all built using strings.
Now, right out of the gate, there's a very common point of confusion when you're actually creating these strings. People always ask, do I use double quotes or do I use single quotes? Well, Python makes this incredibly easy for us. Both double quotes and single quotes can be used interchangeably. Typing Python with double quotes and Python with single quotes will give you the exact same result. There is literally no difference to the computer. It is completely up to your personal preference, giving you the flexibility to just write your code exactly the way you like.
Moving right along to Section 2, indexing and slicing strings. Now, what's really interesting about this is how Python assigns a specific mathematical position, which we call an index number, to every single character in a string. It's like a giant puzzle with numbered pieces. But looking at how Python counts, you'll see a crucial detail. Python starts counting at 0, not 1. So in the word Python, the P is at index 0, the Y is at index 1, and so on up to 5. But Python also gives us a super neat trick with negative indexing. This allows us to count backward from the end of the string. So if you want the very last character of any string and maybe you don't even know its full length, you literally just ask for index -1, and boom, it gives us the letter N.
So if indexing is picking out a single letter, slicing acts like a handsaw to extract specific larger chunks of our string material. The syntax is pretty simple. Inside square brackets, you provide a starting index, a colon, and an ending index. So 0:3 starts at position 0 and cuts out PY. Now pay really close attention here. The ending index number is not actually included in the final cut. That's why 0:3 stops right before index 3. Similarly, if we slice 2:5, we start at T, include H, and stop after O, giving us THO. It gives you this incredible surgical precision over your text.
But hey, what if we want to add to our materials instead of cutting them up? We have two great operators for this. First is concatenation, which honestly is just a fancy programming word for joining strings together using the plus sign. Just like gluing building blocks together, code plus a space plus with Daisy gives us CodeWithDaisy. We also have repetition, using the multiplication asterisk. Python times 3 instantly outputs Python, Python, Python. It's just a very fast, efficient way to repeat patterns without getting carpal tunnel from typing all that extra code.
All right, on to Section 3, essential Python string methods.
Python comes packed with a phenomenal tool belt of built-in methods. Want to yell your text out loud? Use upper to convert everything to uppercase. Need to quiet it down? Lower handles lowercase. Title capitalizes the first letter of every word, while capitalize only touches the very first character of the entire string. We also have strip, replace, split, find to locate a character's exact position, and count to tally up how many times a certain character appears. Having this immense text shaping power immediately available right out of the box is exactly what makes Python so incredibly friendly and powerful for your daily coding. Let's actually look at a practical lifesaver here, the strip method. Imagine a user is typing their email into a form, but their thumb accidentally hits the spacebar a few times before and after their email address. In code, those extra spaces are technically characters, which can absolutely break your database.
But by applying the strip method, Python instantly removes those messy outer spaces, giving us clean, standardized data. It is a true, real-world lifesaver for handling unpredictable user inputs. Another incredibly powerful method is split. Let's say you have a single, long piece of text, like Python, Java, C++, all just sitting in one single string. If you apply the split method, Python will look at the spaces and literally chop that single string up into a highly organized list of individual components. Now, instead of one messy string, you have a distinct list of Python, Java, and C++ that you can easily sort, loop through, or analyze.
Section 4. Formatting with f-strings.
String formatting is what allows us to seamlessly inject variable data directly into a sentence. It's the ultimate custom finish. By simply placing an F right before our quotation marks, we create what's called an F-string. This allows us to use curly braces inside our text to drop in variables on the fly. So if we have a student information portal where the name variable is Daisy and the age variable is 20, the F-string automatically pulls that data to output, "My name is Daisy and I am 20 years old." It's dynamic, it's elegant, and it completely saves us from having to manually glue together a messy chain of strings and variables.
And finally, Section 5, Real-World String Applications.
Let's test our knowledge with a couple of quick mini projects here. First, how do we count the total characters in a string? Well, we use the built-in len function. Passing our string into len immediately returns the exact number of characters, which, by the way, is absolutely perfect for checking if a password meets a minimum length requirement. And what about reversing a string? Think back to our slicing tool for a second. By tweaking those slice parameters, we can actually tell Python to step backward through the text, completely reversing our string with just one single line of code. It's pretty amazing.
Now, as you start experimenting, I want to give you a few guardrails, because there are a couple of very common ways beginners break their code. First up, forgetting quotation marks. If you type the word Python without quotes, Python actually thinks you're referencing a variable that doesn't exist, and it will immediately throw an error. So always use your quotes. Another big one is using an invalid index number. If your string is 6 characters long and you ask for index number 10, you're literally reaching outside the material you have, and you will get an index error. You really got to keep an eye on those boundaries.
So the crucial point is this: string comparisons are strictly case sensitive. To our human eyes, Python with a capital P and Python with a lowercase p mean the exact same thing. But to the computer, a capital P and a lowercase p are entirely different characters with totally different values. If you try to check if these two strings are equal, Python will firmly say false. And this is exactly why those lower and upper methods we discussed earlier are just so important. They help us standardize our text before we try to compare it.
To really cement why mastering all of this matters, just look at where strings are used in the real world. Login systems rely on exact string matching. Chat apps are entirely just systems that send and slice strings back and forth. Search engines, web development, data analysis, and even artificial intelligence. Almost every single major software application relies heavily on the exact same string manipulation tools we just covered. You are literally learning the core language of the modern web.
As we wrap up this explainer, I want to leave you with a bit of a provocative question. Since almost all real-world data is text-based, what are you going to build with your brand new Python string toolbox? I highly encourage you to pop open your code editor today and just start experimenting with slicing, formatting, and all the various methods we've looked at. Practice these skills because they're going to be absolutely crucial when we take the next logical step in our coding journey, moving from single pieces of text into storing multiple values using lists. Keep building, stay curious, and I'll catch you in the next explainer.